Okay, this is an example problem for Physics 1000, Auburn University, summer 2013. I have here a diagram of a parallel circuit that we've already worked with. What we did in a previous video is we found the equivalent resistance of the two resistors in this circuit. So if that doesn't make any sense to you, if you don't even know what I'm talking about, I would encourage you to go back and watch the video of equivalent resistances in a parallel circuit, because we're going to use that result to answer some questions. We've also done some videos on series circuits, which act very differently as far as the components are concerned than parallel circuits. And so we used some rules for series circuits that I'm going to talk about here by way of contrast. But first, let me actually get to what I'm asking you. We know that in a parallel circuit, the current, which I've denoted here by I, when it gets to this point, it's going to split. Part of it's going to go up here through R1, and part of it's going to go here through R2. It's sort of going to break itself into two and go through different paths. And so my question is, what is the current through R2, and what is the current through R1, which I'll call I1 and I2. Let me clean this up a little bit to make it easier to see. And first of all, I just want to talk about how different this is than a series circuit. Series circuits make a lot of sense to me, I think to everybody when you first see them, because the current just sort of barrels through everything. There's nowhere else for the current to go. It's got to go through each component equally. So everywhere in a series circuit you find the current to be the same, but it's not the case in the parallel circuit. There will be a different current in R2 than there is in R1. And it has to do with the values of R2 and R1. However, the saving grace here that allows us to work these problems is the fact that in a parallel circuit, the voltage is the same everywhere. So the voltage that R2 sees is the same as the voltages R1 sees, which is also different than a series circuit. I encourage you to go back and watch the videos on the series circuits if that is an alien concept to you. But we're going to use that here to work some problems. So, that's not what I meant to do. This was 6 ohms. Okay, so the question is, what's the current in R1 and R2? So let's tackle R1 first. We want to know how much of this current, I, is split off and goes through R1 and R2. So, the first thing we need to do is to figure out how much current there is in the first place. If we want to know how much current splits this way, how much current splits that way, we've got to know how much we're dealing with. So to do that, I'm going to use this result here. I'm going to redraw this circuit like this, where this is my 6 ohm resistor. Again, if you really don't see where that comes from, please go watch the previous videos, because understanding them is very important to understanding what we're doing here. So now this allows me to see how much current is coming out of this voltage source. So I can do that really easily using Ohm's law, V equals IR. Rearranging to find the current, which you've done before, you get V over R. At this point I can just plug in some numbers. I know that my voltage source is 9 volts. I know that the resistance that this voltage source is seeing is 6 ohms, which is just 3 halves of an ampere. Voltage over an ohm is an ampere. Reduce the fraction down to 3 over halves. We typically just say 3 halves amps. You can say 1.5 if you want to. I'm just going to say 3 halves. So, hopefully you see this calculation. I'm about to erase it. I'll give you a few seconds to sort of process what just went on. Alright, let me get rid of this guy. That's basically a preliminary step. Now we can actually answer what the question is asking us. So let me go ahead and write in what we know. I'll just use 1.5. It's probably easier to write with the stylus. 1.5 amps. So that's what I have as a current. Now I want to find out how it splits, which is really, really easy. If I want to find out how much is on this leg, well, I just use good old V equals IR, but this time I'm going to subscript everything. I1 times R1. So what I don't know is I1. Remember, I know R1, I'm given that. And I know that V1 is just equal to V because this is a parallel circuit, and that's how parallel circuits work. The voltage is the same everywhere. So I'm going to rearrange again. I'm looking for a current. I1 equals V. I'm not going to subscript it this time because I know that it's just this V right there, over R1, which I get 9 volts over 10 ohms. And I come up with 9/10 of an amp. Now here we need to pause and ask ourselves a very important question. Is this less than the total current I? And in fact it is. You have this 9/10 is less than 1 amp, and over here we've got more than 1 amp. We have 1.5 amps. Remember, this was 1.5 amps is what we started with. So if I were to do this calculation, and I would find that I had, say that I'd calculated this as 3 amps. That wouldn't make any sense. That means I'm gaining current somewhere, which I can't do. I don't have any other voltage sources. You would never expect to find, when you split one current in two, to find those two to be bigger than the original current. That doesn't make any physical sense. So it's a nice little check on yourself, just to make sure that you've got only a fraction of what you had originally, and in this case you do. So, if you've watched the voltage videos on series circuits, you might see what's coming up, but let's go ahead and work it out just to make sure. Now I want to calculate the current in R2, the current that splits off this way and goes to R2. So I do it the exact same way. I'm going to go to a new page, but I've got the current in 2 equals the voltage divided by the resistance of R2. If I plug in numbers, I've got 9 volts. That's terrible writing. 9 volts over, what do I have? 15 ohms? Yeah. 15 ohms. And that equals 3/5 amps. And again, I'm going to perform the same check. Remember, originally, my total I'll call it total here. It's just what I'm calling I over here. This guy here is 1.5 amps. So once again, 3/5 is less than 1. So I've got less current here than I had total, which makes sense. In other words, this is my original current flowing, and it splits off 2 different ways. And I should find less current here than I have here. I should also find less current here than I have here because I'm splitting this current into several different pieces. So I'm pretty confident in my answers. And basically I've answered the question, but in fact I've done it kind of the long way. You might be able to guess just from the fact that the current has, it starts this way and it comes back in this way. The current that splits off and goes through these resistors, R1 and R2, is going to have to come back together at some point. And it would be very strange indeed if we found a different current after it came back together than it was when it split off. It just wouldn't make any sense. There's all sorts of analogies you can talk about that. But in fact, after I calculated this step here, 9/10 of an amp, all I had to do was subtract 9/10 of an amp from my original current, which was 3/2 amps minus 9/10. If you do the math, that's going to come out to be 3/5 of an amp, which is exactly what I calculated here. So in effect, I did some steps I didn't really need to. I should know that the current out has to equal the current going in. It's going to split, but then it's going to come back together later. Okay,